According to WRO 2022 Robomission General Rules, the programming of the robot may be done only by the team. So I have covered a few programming concepts which might be helpful for you to solve the guardian robot challenge in stage 4. But I have not given the direct programming solution to solve this challenge. So let's see what all programming concepts I have for you. The first thing we will learn in this video is the my block. So the my blocks are very important for competitions, especially because when you are making any program for the competition, then the program becomes very big, and if you are able to convert multiple blocks into a single block, then it is very useful for us. So my block palette you can see at the bottom of the screen. So it is blank now. So as we have not created any my block, so it is blank. So let's try creating one my block, how we can do it. So for that I am dragging a few move steering blocks. So for example, going forward one rotation, turning right one rotation, and then coming back one rotation. Now we have to convert this program into a my block. So for that you have to select the blocks which you want to convert into a my block. So like this we can select. So you have to keep one point in mind that whenever you are creating a my block, you should not select the play block along with the blocks which you want to convert into a my block. So I have selected these 3 blocks, and then you have to go to tools and then click on my block builder, and then you will get one option to write name. So for example, I'll write ABC, and you can also write the description for your program, and then you have the icon for the my block. So by default this image is selected. You can change whatever icon you want for your my block, and then you can click on finish here. And if you observe this my block, you can see this plus button. So this plus button is used for adding extra parameters. So we will learn about this later in this video. So now let's click on finish, and after clicking on finish, it will convert the program into a single my block. And now if you go to the my block section, you will see your my block in that, and if you put your mouse pointer on that block, you will see the name of the my block ABC what we gave. And in case if you want to do some changes in your program, then what you have to do is you just need to double click on the my block, and it will open the original program, and then you can do the required changes. So if I want to add one more move steering in this, so it will change in the my block also. So if you go back to the my block where we have created the my block, so if you play this program, it will perform all 4 blocks what we have changed in the my block. So you just need to double click on the block, and then you can do the required changes, and it will be applied to the main my block. So this is how you can create the my block. When you have to move the robot from point A to point B, then you will think that how many rotations we should use so that it can move from point A to point B. So to avoid that confusion and save time, we can use some mathematical formulas and tricks to save our time, and easily we can reach from point A to point B. So for that we need one math block, and we need one move steering block, and I'll be changing it to divide option. So for example, if the distance between point A and B is 100 centimeters, so I'm writing that 100 in A parameter. So now you have to divide this 100 centimeters distance between point A to point B with the circumference of the circle or the wheel. So in my case, I have used the Rembot robot, and in that wheel which I have used, the circumference for this wheel comes 17.6 centimeters. So in your case, whichever robot or wheel you are using, you can measure the radius of that wheel and use the formula 2 pi r, and whatever value you are getting you can write in the b parameter. So in this way, when you divide 100 with this 7.6, you will get the number of rotations, and directly you can take this numeric data wire and connect to the rotation option. So in this way, you can directly reach from point A to point B precisely without thinking exact number of rotations. So this program is very useful for the competitions. And another important thing is that if we are using this program very frequently in the competition, then what you can do is you can convert this program into a my block, which will be very useful for you. So let's understand how we can do it. So in this case, basically we have to convert these two blocks into a my block. So I have selected these two blocks, and then I am going to tools and click on my block builder, and we will write straight move, and icon you can choose whichever you want. You can choose the icon, so I'll choose this one. So previously I was talking about this parameter. So how to use this parameter? So in this case we have to use the parameter options. So we need at least two extra parameters in this. So I'll explain how and what we have to do for that. So just click on plus option. You got one parameter here, and then another one you got here. So I'll click on the first parameter, and then if you go to the parameter setup on this, then you have to write the name for the parameter. So what we have to do here is the first parameter we want to put the distance. What is the distance between point A and point B? So here I'll write DIS, and this should be the input parameter. Data type numeric, data value should start from 0, and parameter type you can select all those things, and then you can change the parameter icon. So as this is distance in centimeters generally we use, so we can select this. So by seeing the icon you can identify what value you have to put it in that. So now the first parameter we have finished. Now let's move to the next one. So this one we have to use for the next parameter, which is power. So if you want to move fast or slow, then you can use this parameter also in the my block, where it will be very easy for you to modify the program. So no need to go to the main program and change the power parameter. And then we will add the power parameter here. So for this we can go to the parameter setup, and here we can write POW, and parameter type input, data type numeric, default value is 0, and then we will go to parameter icon. So as we are using this for power, so we can choose something which is looking like power. Yeah, so this is the second one. And third one, what we can do is we can add the parameter for the circumference. So in case if you are using different types of wheels, then you can modify whenever you want. So go to parameter setup for the third one, and here we will write CIR, which represents circumference, and then you can go to parameter icon, and here you can choose something which is relevant for this particular option. So as this is for the circumference, I'll select this icon. So we have selected three parameters for the my block. This is distance in centimeters, this is the power, and the third one is the circumference. So now we are done with all the parameters which we wanted to add for this my block, and after finishing everything you can click on finish. So now after doing that, what you have to do is you have to connect these data wires to the respective parameters. So this was for circumference. So here we have used 17.6, and then this was for power. It will go to the move steering power parameter, and then this was for distance, so this will go here. So this is inside the my block. Now where we have to go, we have to go to the main my block where we have created it. So it is inside the precise straight move. So now here you can see that all those blocks converted into a single my block, and here when you give some value, so here if I type 100, then this is the distance between point A and point B, and here if you type some value, then it will be the power parameter, and this is the circumference. So whatever value if you type, so it will be the circumference of the circle. So for example, if I type 17.6, so this is the circumference for my wheel. So if you have some other size of wheel, then you can type whatever value you want. So in this way, no need to go to the main program. You can use just single block and do the required changes for your program, and you can make your work easier to solve the challenge. So that's all for the precise straight move. There are three important turnings which you can use based on your requirement, and we can perform all these three turns using move steering and move tank both. So first I'm explaining how you can use move steering to perform all three turns. So the first one is called point turn. So in point turn, where both the wheel goes in different direction but at same power. So one wheel goes forward and another goes backward, but with the same power. So it turns along a single point. So to perform that, you have to use steering value 100. If you are trying to turn right, then you have to use steering value 100. And if you're trying to move on the left side, then you have to move the steering value minus 100. And how fast or slow you want to move, you can increase or decrease the power, and how much you want to move, that is based on the number of rotation. So this was using move steering, how to perform a point turn. And let me just write also so that you won't get confused. So this is point turn, and then second one is single motor turn. So as the name says, single motor turn means one motor is on and another is off. So to perform that, you have to use the steering value 50 or minus 50 if you want to turn left side. So for right plus 50 and for left it is minus 50. So this was using move steering, how to perform a single motor turn. And next one is curve turn. So the curve turn is like all the values except the point turn value, which is 100 and minus 100, and single motor turn, which is 50 and minus 50, and 0. If you use 0, then it will go straight. So except 0, 50, minus 50, 100 and minus 100, whatever value you are putting in the steering value parameter, you will be performing a curve turn. So based on your requirement, you can adjust the steering value and use the curve turn for your challenge. So this was using move steering. Now let me explain you how we can perform the turns using move tank. So before that, let me write this for you. So this was point turn, the second one was single motor turn, and then third one is the curve turn. The curve turn. So now I am explaining how to perform these turns using move tank. So I'll connect a wire from here itself, and now so this is move tank, and as I mentioned that one wheel should go forward and another should go backward, but with the same power. So if I put minus 50 the right motor, then it means the robot will turn right, and if you put this one minus and this plus, then it means the robot will go left side. So this is called point turn. And then if you want to perform a single motor turn, sorry, I need to take the move tank, and if you want to perform a single motor turn, then it's very simple here. You just need to make one power 0 and another one you have to give some power. So if you are giving right motor power 0, it means the robot will turn right, and if you give left motor power 0 and the another motor some value, then it will turn left. And the third one is curve turn. So here you can make so many different combinations of curve turn. So here also, so the pattern is same except this combination where both the powers are same and polarity is different. One is on and one is off. Whatever values you are going to put for this will be the curve turn. So for example, I can put 25 and 30. So this is also a curve turn. If you put maybe 1 and another one 50, this is also a curve turn. So there are so many different combinations can be done for the curve turn. So you can try all these turns using move steering and move tank. Whichever block is easy for you to use for these turns, you can use that. So there is no restriction that we have to use only move steering or move tank to turn the robot. My personal suggestion is that if you are trying to take curve turn, then it's better to use the move steering, because in move tank you have to think a lot that what exact value you should put for each power parameter to take a curve turn. So if you are taking some standard curve turns, so it's better to use the move steering instead of move tank. And in case if you have to do some special type of turn where your move steering is not working out properly, then you can use the move tank. Otherwise, for point turn and single motor turn, it doesn't matter which block you're using, move tank or move steering. For both the blocks, it is exactly same. So that's all for turnings. Do you know how to use a gyro sensor to take a turn? Yes, it's very simple. So you just need to turn the robot right or left based on your requirement, and then give the gyro sensor condition. So for example, if I want to turn right at 90-degree angle, and after turning we need to stop the robot, turn off the motor. So this is the basic program. But the problem with this program is if you want the exact angle, then you have to use very less power, maybe 15 or 20 or something like that. So in this case, what happens when you use this program, it will turn the robot very slowly. So it may take 5 to 10 seconds to turn the robot only one time. So if you're working for the WRO competition, then you have to finish the challenge in 2 minutes. Within 2 minutes, you have to finish the challenge. So if you're taking 5 to 10 seconds to turn the robot just one time, so just imagine if you have 10, 15, 20 turns in one program, then most of the time will go for the turning itself. So you have to turn the robot very fast, and as well as you will get the precise angle. So for that, we won't be able to use this program. So I have another program for you where you can turn the robot faster and also get the exact angle. So let's understand how we can do it. So the first thing is you have to use a repeat block, and then in this you have to take the gyro sensor block. So we will be taking the live data of the gyro sensor, and then we need a math block. So I'll explain each and everything how we are doing it. So I have selected the advanced block. So let me just drag all the blocks required for this program, and after this we need one move steering block. So now what we have to do is we have to make a formula where we can control the power parameter. So here also we have to make it on unlimited, and if we are turning right we will put right, or if we are turning left then we have to make it -100, as I am performing here point turn. So first let's understand how to turn the robot right side. So let's put it 100. Now the output of this math block should go to the power parameter, which will control the power parameter of this move steering. So basically the idea is the robot will start turning with full speed, and as soon as it will start reaching to the target value, the robot will slow down and it will stop very slowly near to the target value. So in that way we will be able to cover 90% of the distance with high power, and at the time when it reaches to the target value it slows down, and then we can get the precise angle. So we will get very less error, maybe 1 or 2 degrees error, and sometimes we can even eliminate 1 or 2 degrees error also. So we have to think about a formula how we can do it. So if you see the engineering notebook, I have given A plus B minus C into D. So let me explain how this formula works. So first thing, you see this B minus C. So what basically I am doing here is, so in B parameter you have to write the target value. So for example, if I am turning at angle 180, so in that case what you have to do is you have to write that value in parameter B. So 180 I have given for B, and then C you have to give the live data of the gyro sensor like this. Now when the robot will start turning, it will start subtracting the values from 180. So for example, 180 minus 1, 180 minus 2, 180 minus 3, and it will reach to 180 minus 180 also at the end. So basically B minus C is doing that. It is directly subtracting the value. So sometimes what happens, if you directly subtract the value like this, then you don't have any control over the robot. So you may get some error, and sometimes if you want the exact 180, then you won't be able to do any changes, because if you are using only B minus C. So that is the reason I am multiplying with D. So what this D will do, it will slow down the robot a little bit. So for example, if I multiply this B minus C with some decimal number, for example 0.7, so it will decrease the speed of the robot. So in this way you will be able to increase or decrease the speed based on the requirement. If you are getting more error, if I give 1, so it means it is exactly like B minus C. So if it is giving you some error, then you can reduce the power of the robot. So I can multiply this with number 7, so it will reduce the power parameter for the robot, the turning power, and you will get the less error. So this is how you can control the speed using B minus C into D. And why I have given this A parameter is, so in case if your robot is reaching at angle 175 and your power value becomes 0. So it depends on the D value what you have given. So if you are giving some value, let's say 0.6, 0.7, whatever, and at angle 175 or 176 or whatever, it could be maybe 179, and your robot power is so less, so it cannot push the robot to angle 180. So for that we have to give a little push at the end, and we can give that A parameter as value 5 or 10, anything. You can give a very little power to just give a small push. So this formula works on the board mass rule. So it's like B minus C, first it will calculate B minus C, then it will multiply with D, and then it will add to A. So on the safer side, to give a small push at the end, I have given the value 10 for parameter A. And then this output will go to power here. So this program will start turning, and when it reaches at 180 it will slow down and we have to stop there. So now this is only about turning and slowing down the robot, and now we have to stop the program when it reaches at 180 degrees. So for that we have to change this condition for the loop to 180 degrees. So I'll select the gyro sensor angle, and if it is greater than or equal to 180, then the robot should stop there. So I'll turn it off. So this is the program for turning right at any angle. And one more important thing is that if you are using this program multiple times in your main program for your competition, then you should use the reset block also here and make this reset. And what you have to do is, if you are using multiple times in main program, as I mentioned, you can also convert this into a my block, and the process is same. You have to select all the blocks and then go to tools and to the similar steps to convert into a my block. So in case if you're not giving the reset block here, then in the main program, wherever you are using this as a my block, you have to give the reset block. So it's better to add the reset block in the main program itself. So now let's move to the left side turning, how you can turn the robot on the left side. So this was turning right, and there is a slight change how we can turn on the left side. So I have selected this program. I'll just copy here, and what you have to do is, for turning left, you have to first change the target value here. So here you are turning left side, so the condition will be less than equal to, and as we know, the angle on the left side is negative, so you will write minus 180. And in the formula also we have to do some small change, is instead of b minus c, we have to give b plus c. So now the formula will be a plus b plus c into d, and here the value will be same, so 10 180. So plus I have given, because now 180 plus c means the gyro sensor will give you negative number, and 180 minus 1 minus 2 minus 3, like that it will come, and then it will start decreasing the power when it reaches towards the target value. And another change what you have to do is, you have to turn left side, so the steering value will be minus 100 instead of plus 100. So only this few changes you have to do for turning on the left side. So for this also you can convert into a my block and use in your main program for WRO. So that's all for precise turning using gyro sensor. In the previous stage, you must have seen that I have detected the grass using ultrasonic sensor, and then I cut the grass. So let's see how you can detect the object using ultrasonic sensor. So for that, what you can do is, you have to move the robot forward on unlimited, and in this case I would suggest that you use a little less power only when you are trying to detect any object, because the object size like bad weeds or grass are little small, and if you move your robot very fast, then you may not be able to detect those objects. So move a little slow for that. So I'm using power 10 only for now, and then you can use the ultrasonic sensor. So based on the distance, what distance is there between ultrasonic sensor and the object, and also it depends where you are connecting the ultrasonic sensor in your robot. So in my case I have used distance 8 in compare mode centimeters, so it will be less than equal to 8, and then you can stop the robot there. And after stopping, you saw that I moved the arm, the medium motor, to cut the grass. So for that you can use one medium motor, and in my case I used little less power for that. That was enough for it to cut the grass. So 15 and degrees I used 200 to move in one direction, and then again it has to go back to the same position. So for that I used power in negative so that it can go back, and then the degrees value 200. So in this way you can detect any object using ultrasonic sensor, and then you can do the required action. So I move the medium motor to cut the grass, or you can also use this for collecting the weed. So that's all for detecting the object using ultrasonic sensor. Whenever you use the color sensor in the reflected light mode in different light intensities, then it is a good idea to calibrate the color sensor before you run the program. So basically the calibration program teaches the color sensor which is white and which is black. So let's understand how we can make the calibration program. So first of all, you have to reset the color sensor before you calibrate it. So in the calibrate option itself, at the last you will get the reset option, and then we have to use some condition to stop, so that we get some time to go on black or white. So here I am using the brick button, compare, and I'm using the center button. So basically the program will wait for me to press the center button, and then it will go to the calibration program. And then I'll be using the color sensor. So in the reflected light mode, and then we need another color sensor block, and here we have to choose the calibrate option, reflected light intensity, and it is minimum, and then connect the data wire to this. So basically this calibration program will teach the color sensor that is black. So what you have to do is you have to put the color sensor on the black color. So make sure the color sensor light which is coming out of the sensor, the red light in the reflected light mode, is completely inside the black color. And then you have to press the center button, and then it will calibrate it to 0. So basically it means whenever it sees black, it will sense it as 0 in reflected light mode. And then just to inform you, it has detected it properly, we can add a sound block saying it as black color. And then same thing we have to do for white. So what I'll do is I will just copy this and add it here, and now here we have to change it to maximum, as we want to make it white color, the maximum value. So I have just changed it to maximum, and then at the end you can, instead of black, you can change it to white, and this is how you can make the calibration program. So you have to reset the color sensor first, then wait for some condition. So I'm waiting here for the center brick button, and once you press that, it will calibrate the color sensor to the minimum value, the black, and then it will play the sound block just to confirm that it has detected the black color. And then again it will wait for us to press the center button, and then it will calibrate it to maximum value, which is white, and then again it will play the sound block. And in this way you can calibrate your color sensor. Now after the calibration, you can program your robot to follow the black line. So let's understand how you can make a black line following program, a smooth black line following program. So for that we need a loop, and then we need a live data of the color sensor in reflected light mode. I'll change it to compare measure reflected light intensity, and then we need a math block in the subtract mode, and it will come here, and then here I will write 50. So why I am writing 50 here is, so if the color sensor is following the line at the edge of the black line, so what is the target value? So after calibration, your color sensor will be getting 100 on white and 0 on black. So if I am trying to follow the line at the edge of the black line, so it means somewhere 50 I am getting on the edge of the black line. So in that case, we are subtracting value 50. If you have some other target, if you want to give 60 or 70 or 40, it depends on you at what edge you want to follow the black line. So I have given 50 here, and then I have to use one more math block, and I will put it in the multiply option here, and then put the data wire to a parameter, and here we can multiply with some number. So for example, if I multiply with 6.6, and then here I will take the move steering value and make it on unlimited, and then the output of this math block will go to steering parameter, because we have to control the steering as it is following the line. If the line is taking turn, the robot has to also move along with the line. So if it is having a sharp turn or a different type of curves, then it is turning based on the value what you have given here. So if you don't have a sharp turn, then you can reduce this value. If you have a like more sharp turns are there, you can increase or decrease the value for this. So you have to fix this value. So you have to keep on trying, and you have to check that which value is suitable for you. So this 0.6 is not fixed value for any program. So based on your requirement, you have to do trial and error, and then you have to come to the conclusion which value is suitable for that. So this is not suitable. 0.6 is not suitable for all the teams here, because it could be different values for all different teams. So don't try to remember that 0.6 I have used, so it is similar for all the teams or all the color sensor or robots, whatever you are using. So if there are 10 robots in the classroom, so this value could be different for all 10 different teams. So try to come up with the final conclusion based on your own research, what value is working best for you. And you can also control the power parameter. So if power 50 is working fine for you, that is good. If you want to go a little slower, you can make it 30 or 40 and see which value is working best for you. So this is what we have for the calibration and proportional line follower. In the Guardian Robot Challenge, we have many 90 degrees turn. So if you are following the black line and you have to stop the black line following at 90 degree turn, and after that you have to take a 90 degree turn and again start following the line. So how we are going to do that? So let's understand it. So this is the program using which you can follow the line, and as you need to stop at the sharp turn, the 90 degree turn. So for that you have to do a small change. You just need to change this unlimited to the color sensor reflected light intensity, where you can give greater than or equal to maybe 90. So this 90 value I am giving because if the robot is following the black line, then your color sensor might be getting values around 50, 60 or maybe somewhere near to that. So if it reaches at the edge, at the corner, then the color sensor will come almost on the white line, the white surface after the black line. So in that case, as soon as it comes outside of the black line, it will detect more value. It could be greater than 80 or 90. You can just check what value you are getting. Based on that, you can write this value here. I am giving 90. So as soon as it detects more than the previous value, the robot will stop. So you can give one turn of the motor block. And this is how, while following the line, when it comes at the edge, the 90 degree angle, it will stop the motor. And then you can use the turning block. You can turn right or left based on your requirement. And what program we learned, that gyro sensor precise turning, you can also convert that into a my block, and one single block you can use for turning. So this is how you can follow the line at the sharp edge and stop at the edge, take a turn, and then again start following the line. At the end of the stage 4, I have given some mini challenges based on the Guardian Robot challenge itself. So you can check the engineering notebook for the challenges. So here I have mentioned some points. So these are not printed on the mat. So this is just to give some reference for the mini challenges which I have given in the engineering notebook. So like point A, B, C, D, and high grass, bad weight, I have mentioned all the names. So using this references, I have made some of the mini challenges. So I would highly recommend that solve all these mini challenges, which will be very useful for the main challenge.